Okay, one more thing on the Brownie problem. I just want to point out in mathematics we'd like to simplify things as much as possible. So when we look at a term like this, 2/3 times 1/3 times 1/3, we see the 1/3 times 1/3. We can simplify that and just write it as 1/3 to the second power. So that simplifies that term a little bit by using exponents. If I go to this next term, it would be 2/3 times 1/3 to the third power. And then sometimes when you do that, it makes it easier to extend it. The next one would just be 2/3 times 1/3 to the fourth power. Let's go back in this direction. This term would be 2/3. If I want to be consistent and make every term look like every other term, that would have to be 2/3 times 1/3 to the first power. But that seems to make sense because look at the exponents. Look at that pattern, 3, 2, 1. I'll go to this first term right here and say, I want to do the same thing. So this is 2/3 times 1/3 to the, well, if I look at this pattern, 3, 2, 1, it must be 0, and that's true. Any number to the 0 power is going to turn out to be 1. So this is a good justification for why we use these exponents of 0 and 1 the way we do. In this case, it really makes our sequence here of terms very consistent. So the only other thing I want to do with this is point out that really this is very similar to another topic we covered in a different video on Zeno's paradox. Really interesting paradox that's over 2,000 years old. So Zeno's paradox and the Brownie problem, very similar problems.